Hello, my name is Dr. Makita Linear von Quajian, and today we're in our laboratory trying to solve the mystery of quarantine. We have some questions for you today that we need your help. So come on into the lab and let's get to work.
Hello again, this is Mr. H, the fake scientist, so everything that I explain to you today probably won't make sense. Now, we are very close to creating an antiviral drug. You can see the shape of the drug here. This is imagine a square, 7 by 7 square, with some rectangles cut out. The dimension of the rectangles that are cut out of this square are 6 by 1. So the way the antiviral drug will work is a virus likes to attach itself to a cell using receptors. It's kind of like this pen. The cell itself is the pen. The virus has a little thing sticking out that's like a cap. And it attaches itself to the cell like a pen attaches itself to a cap. Or a cap attaches itself to a pen, whichever way you want to go. The point is, a cell, if I were to lay it out two-dimensionally, a cell has an area of 8 by 40 or 40 by 8. My antiviral drug is shaped like this. It's like a 7 by 7 square, again, with 6 by 1 rectangles, 3 of them cut out of it. How many of these antiviral drug shapes can I fit in a 8 by 40 area space?
What up, my quarantine math people? Back at it again from the lab. We are so glad you joined us this week to help us figure out how many antiviral drugs we could fit into the cell. Obviously, we have no idea what we're talking about because we are just math teachers and songwriters and rappers, might I add, and not scientists. So probably everything we said was wrong, but that's okay. We're going to solve this math question. All right, so the question asks us, how many of our antiviral drugs can we fit into this rectangle, basically? All right, and we're going to show you two different ways to do this. We're going to show you first the visual way, and second, the mathematical way. Okay, and the problem with the visual way is that the microscope that we were filming under in the lab didn't allow you to show the correct proportions of our antiviral drug and our cell. They kind of look like they were the same size, and obviously that's not true, but that was just the microscope, okay? Nothing with the people who were actually drawing the pictures. So visually what we want to do is we want to see, okay, how many of our antiviral drugs can we fit here? Now, if you notice, this kind of looks like a long rectangle right here and then kind of teeth coming out of it, all right? So what we want to do is we're going to duplicate this. And then we're actually going to turn this because like a puzzle piece, and again, this is visually, okay? So this is, some people might not understand this. You definitely might not have thought this far through and might have solved it mathematically, and that's totally okay. But we can put these together. The teeth are going to fit perfectly together. Now, you're still going to have little spots right here where it didn't cover, and that's okay, all right? So now if we take this and we start filling up our rectangle with it, we know that the length of this side was 7, and that this part has to be 1, so the 7 plus 1 is going to equal 8. So even if your proportions wasn't right, you could do the math to figure out that if you put these two together, it's going to have a total length of 8. And then if you duplicate it, okay, and just keep drawing them, you can see if you fit them right next to each other, all right, that our total length is also going to be 8. So even if you didn't draw it out proportionally, if we know that the length of this is 7, and then we said that the length of this small rectangle was 1 by 6, right? That was the area that was missing. So we're going to have a total length of 8. And you can do the math maybe in your head already, but we're going to be able to fit 5 of these groups side by side in our rectangle. So again, even if you didn't draw it out proportionally, that's okay. So we'll be able to take another group right here and fit that together. And then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to have these little spots that we weren't able to cover with the antiviral drug, but that's okay because we didn't ask you how many you needed to completely cover. We asked you how many could you fit inside the rectangle. So you're going to have a remainder if you did it mathematically, and that's okay, but the answer would be you can fit 10 antiviral drugs. Now let's take a look at it mathematically. The mathematical way of doing this requires us to find the area of the cell. So when we do length times width, we figure out that there's going to be 320 square units that cover the surface of our cell. We need to figure out the area of our antiviral drug. So there's two ways to do this. We know that the antiviral drug is missing these three parts, right? It's like these three parts right here were cut out. So that's not part of the cell. So then there's two ways to find the area of this irregular shape. We could split it apart into 5 different rectangles and find the area that way. Or we could figure out the area as if it were a complete rectangle and then subtract the parts that were cut out. Both of those ways are going to give you the same answer. The way I'm going to do it for this question is I'm going to complete the rectangle, act like it's a full rectangle, find the area, and then subtract the parts that were going to be cut out. But either way, you're going to find the same answer. So if this is a full rectangle, the length and width is 7, which gives us an area of 49 square units. Now, he told us that these parts were 6 units long and 1 unit wide, which means length times width. Each of these parts that is cut out has an area of 6 square units. I'm not going to label all of them just to save some time, which means the total area of the part cut out is 6 times 3, which is 18. So if I subtract the 18 square units that were cut out, that leaves me with an area of 31 square units for my antiviral drug. Now the question is, how many groups of 31 can I fit into 320? To figure that out, I'm going to do a tape diagram. Some of you might not have done the tape diagram, but I love having a visual model. I know the total area is 320, and I'm trying to figure out how many groups of 31 can fit in. So each group is 31 square inches, which means the 31 is the parts of my tape diagram. And I want to keep adding these up until I get 320. So 1 antiviral drug, 2 antiviral drugs, 3, ... How many antiviral drugs can I fit into 320? Well, the equation that this is asking me is blank groups of 31 fit into 320. But to solve this missing factor, I need to rewrite this as division. So I'm going to divide 320 divided by 31. And that's going to give me 10 antiviral drugs with a remainder of 10 square feet, which makes a lot of sense because when I went back to my visual model, there were 10 sections, each of them was 1 square unit, that were left over that I couldn't cover up. So this is the exact same answer I got as when I did it visually. It's not asking me to do anything with my remainder though, it's asking me how many antiviral drugs can I fit, and the answer is still 10. Either way you did it, visually or mathematically, you get the same answer. Depending on what type of learner you are, you could have picked either strategy. Join us next week for episode 2. We really appreciate you spending your time with Quarantine Math today. As always, stay safe, do math. I'm out.